Chapter plan. Okay. Hello everyone. Welcome to Fireblaze AI School live series on YouTube, wherein we explore a lot of topics every week. So the topic for this week is sampling methods in machine learning. So now some of you might be aware about this topic, what sampling methods are. So sampling methods, right? So what do you understand by sample? Now, even though these methods are useful in machine learning, we don't usually only use that for machine learning. We also use that when we are performing statistics. So sampling is a part of statistics. So what do you understand by sampling? So sample, for example, okay, an example in itself is a sample, right? So wherein we, go to a market, we see or we go to buy some vegetables. What we do is for recognizing which, what you can say, which vegetable looks good, you don't test all of them, right? You sample a random vegetable from there, for example, a tomato. So what you'll do is you'll sample a random tomato from there and check if that tomato looks good. Maybe you will sample a few more, and if all of them looks good, you will buy those tomatoes, right? Because you are sampling uh, the uh, the tomatoes from the whole population of tomatoes. Okay, so these are the concepts which we'll talk about in the upcoming slides. So this is all a part of statistics. So first of all, what is statistics? So statistics is a mathematics which helps us organize, collect, and analyze the data. Statistics is a basis of data analysis and data science. Unless understanding statistics, you cannot understand the data, right? So that is what statistics is. Now the statistics, it is broadly divided into two categories. One is descriptive statistics and one is inferential statistics. So descriptive statistics talks about the data, that you have. For example, if you are having, let's consider the same example of this tomatoes. So you see those tomatoes and we are talking about all the tomatoes. So when you describe all of these tomatoes, for example, the count of tomatoes, the if for example you are considering the diameter of that tomatoes, so you'll be measuring the sum of the diameters of all those tomatoes, the average of all those the diameter of all those tomatoes, the maximum diameter of a tomato, the minimum diameter of a tomato, and likewise. So when you describe your data, that is called as descriptive statistics, which includes functions such as sum, mean, max, count, likewise median, there's variance, standard deviation, right? And there's another which is called as inferential statistics. Basically, inferential statistics is when you make an inference out of a statistic. So consider this, that there's a market where there are various vendors who are selling tomatoes. And what you do is you go to one vendor and you check a few samples or the whole box of tomatoes, and you infer from that this looks good. You infer from a few tomatoes that this whole box of tomatoes look good. Then you move to another vendor, you check, you do the similar thing for the same box of tomatoes, and you sample a few tomatoes and you infer that this tomatoes or this box of tomatoes looks good too. And likewise, you go to a few vendors and then at the end you infer that wherever these tomatoes were sourced from, you can say definitely or confidently say that these tomatoes are good or are of good quality wherever they have come from. So you see how you inferred from a few samples about the whole population of tomatoes. So this is called as inferential statistics. When we use a small subset of a data and we make an inference of the whole population based on the subsets, various subsets of data. So that's what my next slide is about. These things or these subsets and the complete set is called as the population and sample. So the complete set of data is called as population, and whenever we sample a few data set is called as a sample, right? So it should not be what is sampling, but what is a sample, right? So I need to change that in my slide. So what is sampling? Sampling is an, you can say, is a science or is an art or a combination of art and science of choosing the correct samples for your statistics modeling. So you need to select, for example, if you want to perform some kind of, you can say, maybe considering, let's consider an example wherein there's an assembly line and you are manufacturing a rod of a certain diameter, and you need to check whether the CNC machine is producing the rods with the set diameter or not. There's some tolerance that would be allowed to it, but you need to check if the diameter is matching the tolerance or not. Now, if you keep on checking, for example, if that company, if your company is manufacturing 1,000 parts per minute, is it possible for you to check all these 1,000 parts in a minute? It's not, right? It's crazy to even think about doing that. So we are not able, we won't be able to check that. And so what we need to do is we need to sample a few parts out of them. So what we can do is we can choose a time. For example, at 12 o'clock, I'll sample 5 random samples. And then at 1 o'clock, I'll sample next 5. At 2 o'clock, I'll sample next 5. Depending on how to identify your root causes or your specific causes, you need to select what sampling type would be best suited for. Okay, so that's sampling. Sampling is just selecting a representative subset from the whole larger data set. Right. Now, why is sampling so important? But sampling is important everywhere. Wherever you use statistical modeling, sampling is important. I just told you an example of sampling in manufacturing. You use sampling in quality testing as well. There's a lot of things wherein you sample things. But what's the importance of sampling in machine learning? We need to learn this today. First is faster model training. Whenever the sampling is correct, if we do the accurate sampling or important or we sample all the important points, we can be able to model our or train our model in a faster way, right? It also reduces computation. For example, uh, considering our data set. So before I talk about this, you need to have some knowledge about machine learning and how it works. But if not, it's fine. You can, note down this point and then you can take this into consideration whenever you will be learning ML in future. So the second point, reduced computation. Consider this, that you have trained your model, but actually instead of training, you have overtrained your model. Your model tends to work very efficiently while training. But you later realize that your model would have trained better even if you would have used 50% of the data points rather than using all of them. So this is the case of what you can say, overfitting. You have trained your model using data, even more data, more than what was required. Okay, so what needs to be done in this case is we could take samples, various samples of this model, and then perform this machine learning, hence reducing the computation time and reaching the output faster, because that was the first point. If we reduce the computation, definitely we will be reaching our goals faster. It's obvious. Balanced data. So some of the times what happens is we get imbalanced data. For example, if I want to categorize whether a person has diabetes or not, or whether my email that I've got is a spam or not, it's possible that the data that I have got, for example, if I have 1,000 data points and 800 of them are for the output that these are spam emails, and whereas 200 is for these are non-spam emails. So this kind of data is what? It is an imbalanced data because the outputs are imbalanced. The ratio is 80 to 20, right? And that's why I need to, whenever I need to use balanced data, we use sampling. There are several techniques such as SMOOT, which we'll be talking about later. So SMOOT stands for sampling minority over sampling techniques. So we'll be talking about that, and then for better generalization. So if you want to generalize our machine learning model on our specific data, we can use sampling, and that's why sampling is used in machine learning. Let me take a example. So instead of training our model on millions of customers, what we can do is we can use a subset of these customers, and not just one subset. We can, for example, if there are millions of customers, we can train this model on maybe 10 subsets of 1,000 customers each, or maybe 10,000 customers each. So that would make up to just 0.1 million of customers, right? 1 lakh is 0.1 million instead of working on 10 lakh customers, right? So I think 1 lakh points are enough for the data or for the predictions to converge to the most accurate prediction that can be possible. So thus we can use sampling and save the computation as well as make our results faster. Also, we need sampling to increase the efficiency and scalability of the project. We can speed up by sampling, just like I talked about before, wherein I told you that speeding up or making the process fast by reducing the computation time, by reducing the amount of data required. And we can also we can also become able to work with massive data sets because of sampling. Also, we can reduce bias in machine learning by sampling, because it's possible that the data that we have entered has some kind of bias which leads to underfitting. What is overfitting and underfitting? We need to learn machine learning about that. But reducing bias with the help of sampling, we can also reduce this bias. So whenever we have a problem of underfitting or undersampling, we can use sampling methods to reduce the bias in these machine learning models. Again, just like I said before, we can handle the imbalanced data by some oversampling and undersampling techniques, some of which I will be discussing later. Now, how many types of samplings are there? So this sampling can be broadly classified into two types. There's probability sampling and there's non-probability sampling. Now, each of them, they have their own purpose of sampling. Now, there's one basic difference between these two. Probability sampling makes sure that each of your, what you can say, each data point in your data set gets an equal probability of getting selected into a sample. Right? Try to understand what I'm saying. For example, there are 10 students and I need to pick one at random and take his feedback about my teaching. So if I keep them seated in front of me and choose anyone at random, that means each one of them have an equal probability of getting selected, right, which is 0.1. But what if I am biased, not because of my own reservations or something, but I'm biased because that's the purpose of my study. I am selecting all those students who were present in my class, right? Because if I need to take a feedback, I need to take the feedback from the students who have attended my class. Why would I even choose them who were absent in my class? Correct. So if there's some kind of bias, which means that okay, let's consider seven students. I'm biased towards asking this to this seven students. So definitely these seven students, the probability of them getting selected is much higher, or you can say is at least something. But probability of the three students that were absent from my class is zero, right? So each one of them does not have equal probability of that of getting selected in the sample. So this type of sampling is called as non-probability sampling. It is not unfair. It is just how the situation is, right? Whatever the situation demands, according to that we need to perform the probability or the sampling technique. We need to choose what kind of sampling we need to choose for our machine learning model. Okay. So of this probability sampling, there are four types of different probability samplings, whereas for the non-probability there are same four number of sampling types. Let's discuss these sampling types one by one. So first is simple random sampling. It is as simple as it gets. Basically, you have a pool of 100 students and each student has an equal chance of getting selected. For example, I am sitting here and I've asked them to put their numbers in a random bowl, and I put my hand in a bowl and I take out a number, and that number has whatever that number has, whatever student that number is associated with, would be asked to come into forward and be the part of my sample. So it's as simple. Everyone has an equal chance of getting selected. There is no bias in anything. There is no uh, categorizing them into various categories before I choose them for my sample. Okay. So this is a simple random sample, right? Then comes stratified sampling. So what happens is in stratified sampling, the data is divided into various strata. So strata means we can say a category. So what it says is it divides data into strata, and from each strata they sample, right? So this is good for imbalanced data. Again, just I said before, like I said before, if your data is imbalanced, right? If your data is imbalanced, what you can do is this kind of sampling is best suited for that, the stratified kind of sampling. So what we can do is, for example, if I have 80% of data for the spam folders, and if I have 20% data for the good emails, right? The good emails. What I'll do is I'll take 20%. So whatever the 20% is, for example, out of 1,000 data points, 200 are non-spam emails and 800 are spam emails. What I'll do is I'll take 100 from the spam emails and 100 from the non-spam emails, making it a sample of 200, and then select multiple such samples to create this stratified sampling. You're getting my point? How I took a few data from this imbalanced data to create balanced samples. And whenever I would be performing machine learning modeling on this multiple balanced samples, there's a huge probability that my machine learning model will work to its best. So this is stratified sampling. Now comes systematic sampling. So systematic sampling means I'm selecting every kth point data point, which means, so for example, it's given every 10th record, I can select whichever number I want. So for example, in a group of 100 students, what I'll do is I'll select, starting from the second guy, I will select every seventh person for my sample. So if the first person I'm selecting is the second person, then 2 plus 7 is 9. So the next point in my sample will be the ninth person. Then again adding 7. So 9 plus 7 is again 16. So 16th person would be my next in the sample. And then likewise, I'll keep on selecting every seventh person in my sample, and that's how I would be doing the systematic sampling. Again, because of this, every person has an equal probability of getting selected in my sample because I have not divided them into various categories, right? Each one of the person has an equal probability of getting selected in my sample. All right. After that, let's talk about cluster sampling. So, cluster sampling, as the name suggests, it creates various clusters. So, for example, I have this 100 students, and what I'll do is I'll divide them into 10 different clusters, of random clusters, like 10 students in cluster 1, 10 in cluster 2, and likewise there will be 10 clusters in front of me. And what I'll do is I'll choose one whole cluster from there, and I'll choose that as my sample, right? So again, you might think that this is unfair for the others because they are not included in the cluster. But you need to understand every sampling has its purpose. Every type of sampling has its purpose. No one of the sampling is unfair and no one of the sampling is wrong. Each sampling is has its own purpose to serve. So you cannot name any sampling as wrong or unfair or anything. It's just purpose here that your sampling needs to perform. That's it. Right. So this is cluster sampling. What happens is you create various clusters and you select one cluster at random and then you perform sampling and then you whatever you are doing survey, you are to ask about them a few questions and take their opinions and then you on those opinions you need to decide something. That is called as cluster sampling. Okay. So these were the four probabilistic samplings. Which ones? Simple random sampling, stratified sampling, systematic sampling, and cluster sampling. Now let's talk about the non-probabilistic sampling. The okay. Before that, let's talk about the use cases of probability sampling. Okay. So first is fraud detection. Just like I told you before, if I need to detect the fraud in, for example, this is spam emails, I can use this probability sampling. More specifically, the stratified sampling. I could divide the data into two stratas based on their selection, and then I could easily create a sample balanced data or balanced sample data. My bad, balanced sample data to create a machine learning model for fraud detection. So fraud detection is something that we can work on. Again, churn prediction is also something we can work on. Why? Because usually churn is a phenomenon of a person leaving your company. So in a company, you would see if your company has 10,000 customers or maybe an app, if you're working on an app has 10,000 subscribers, the amount of people who have left your app or left your company or customers who have left your company is little. So if 10,000 out of 10,000 there would be somewhere around max to max 1,000 students or sorry 1,000 customers who would have left your company or unsubscribed from your app. So if you see, these are just 10% of all the population, right? So again, if you chalk out the data, you will see that there's again imbalance in the data. 90% of the people have not left the app and are still the customers with our company, whereas 10% have left it. So again, if I want this again becomes an imbalanced type of data. And again, if I want to create a balanced data set, I can use the sampling techniques to make it balanced. And then once we create these balanced samples, then the machine learning model tends to perform a bit better than before. Right? Again, the third type of or third use case of this probability sampling is real-time analytics. If I want to do real-time analytics, probability sampling is good because real-time data is huge in number. Right? Just like I told you before about the manufacturing data, the manufacturing data is real-time analysis, right? There's parts they keep on manufacturing, they keep on coming, and it's not possible for you to sample each one of them and test or perform your quality test on each one of them, right? So what you need to do is at random select any part and then perform your quality analysis on them. So real-time analytics requires the probability sampling type of sampling. right? Now, let's talk about the non-probabilistic sampling. So first in that is the convenience sampling, right? What is convenience sampling? Again, all these types, their names suggest what they do, right? You don't have to look for anything else. If you are good at English, you can understand what convenience does, right? So what does convenience mean? Convenience means the thing that is convenient to me, which is easy for me, or that is comfortable for me, right? I will think about myself first. So this is basically what it uses readily available data, right? So what you can consider as readily available data. Let's take this example in our minds. For example, there was some elections happening in my state a few years or maybe a few days back. Right now, I need to take opinions from the public whom they have voted, just in case to get an idea about which party might win. Right, these things like this happen when we are what you can say when the elections are around. You can see there are a lot of opinion polls और हिंदी में कहे तो रुझान जिसको कहते हैं. So opinion polls, they keep on coming on your screens in your newspapers, in your Twitter feeds, in your LinkedIn feeds nowadays. LinkedIn has become a social media platform nowadays. Maybe in the news channels that you see, you know. So people like these news channels, what they do is they sample people based on their opinions, and then they predict what can be the outcome, right? So one such non-probabilistic sampling is convenience sampling. So for example, I am currently at none. So someone asks me to do the same kind of opinion polls. So what is I will think what is convenient to me. The most convenient thing for me to take opinions is to just get out of my building and select anyone at random and ask his or her opinion about the elections, right? And I'll sample 100 such people who I find the first. Basically, what? Readily available data. You know, whenever I get out of the building, the readily available person in front of me, I'll just ask him or her his opinion, and that would be my data. And this kind of sampling is called as convenience sampling. Why is this non-probabilistic? Because the people who are residing near my office in Nandanvan gets the maximum chances or maximum probability of getting selected in my sample compared to those who do not live nearby, right? So that's why the probability of people living here near my office is more, or you can say it's very high compared to the people who are not around. So that's why it is a non-probabilistic kind of sampling. Clear? So this is why I don't know why am I even asking you, because I know you won't be able to answer me. But anyway, so this was convenience sampling. Now the second is judgmental sampling. Okay, so judgmental sampling is as it's written in the line beneath it. Experts select specific data subsets. Okay, now let me simplify this line for you. For example, if you might be aware about this. So for example, let's talk about economy. So Nirmala Sitharaman, our finance minister, whenever she gives budget, now for example, she gave some budget to AI this year's budget. I cannot remember exact number, but she did put out a huge chunk of money for the AI development this year, right? So if you need to know about the opinion about the people, if she did good or not about, or if people are happy about the AI thing or the AI budget that she gave, would you ask this to someone who is an expert in AI, or would you ask someone who is driving an auto rickshaw? So again, I'm not judging a person. Maybe the person who drives an auto has some kind of knowledge which I mean a scientist does not have, right? Everyone has their kind of knowledge. I'm not demeaning anything, but the thing is, this is fact that a person who drives an auto rickshaw is not working in the field of AI. So that person won't be aware about what the budget in AI is, right? So simply, he is not an expert at AI. That's all I want to say. So judgmental sampling is asking the expert in that field about that AI or about that opinion. So that's why this makes it a non-probabilistic kind of sampling. Why? Because the people who are not experts in that field have little to less probability or little to no probability of getting selected in the sample, whereas the people who are experts in that field would have a probability, a higher to one probability of getting selected in that sample. So this is judgmental sampling. All right. Then comes quota sampling. Quota sampling is usually again stratified. It is a kind of stratified sampling, but with a tinge of non-probabilistic method. Right? Ensure sample matches key characteristics like age or gender. But this kind of sampling is based on demographics. So, for example, I'm a owner of a company who is selling baby products, right? Not just baby products, but products related to children below 15 years of age, right? And I need to do my opinions. I need to get my opinions for my sample, and I need to reach out to various people. So, what do you think? Should I ask about the feedback to? Should I ask it to the old people, maybe 60s and 70s, or to the children who are under age of 50? Exactly, to the children who are below the age of 50. It's obvious, right? So what I'm doing is I'm selecting a quota, I'm selecting a strata or a class or a demography, whatever you can say, and I'm asking them the opinions, and I'm discarding the people who are not associated with this thing. So what I'm doing is I'm creating a quota, and then I'm asking. So I'm just not discarding completely the people who are above 60. I'm also giving them a small percentage of weightage. So for example, for the children between 0 to 15 years of, not 0 to 15 of course, 5 to 15 years of age, I'm giving 60 to 70% of weightage. Then above 15 and below 60, I'm giving them 20%, and above 60, 10%. I'm giving them small amount of weightage because some of them are parents, and parents sometimes are better able to express what their children wants. Right? That's why I'm not completely discarding them, but giving a smaller weightage. And this is how I create a quota. 70% of quota for the children between below 15, 20% for between 15 to 60, and above 60, 10%. So this is called as quota sampling. Again, you can see that because I'm giving, there's my bias involved, 70%, 20%, and 1, sorry, 7 is to 2 is to 1, the ratio, and which is non-probabilistic, which is not equal amongst all people, right? So that's why it is called as non-probabilistic sampling. And the last one is snowball sampling. This is the most common type of sampling which is used nowadays, which is to refer others. So basically what I'll do, I'll create a form, I'll select a person at random, and I'll ask him to give me feedback, and then I'll ask him to refer 3 others for this feedback. So what I'll do is he'll refer 3 others, and those 3 will refer 3 others, and likewise a snowball sampling will form. Why is it called a snowball? It's just like throwing a snowball at someone. So I'm throwing this snowball of feedback at one person, and that one person is throwing the snowball of this feedback to 3 different persons, and those 3 are throwing a snowball at 3 different persons. So this is just like referring others, and that's why it's called a snowball sampling. I know it's not very, this is very counterintuitive when it comes to thinking what would be a snowball sampling. But anyway, that's the name given, and we need to learn the same. So this is again, and again, the people who are like the person who I have referred to uh, would have a weightage, would have a higher probability of getting selected, and all the people who are his friends would have a higher weightage of getting selected in the sample rather than someone who's not. So that's why it is called as non-probabilistic kind of sample. Now again, There's one thing, because it's possible, bias happens in non-probability sampling a lot. There's a greater risk of bias because it's easy, because it's non-probabilistic. There's a lot of people who don't even have chance of getting selected in the sample, and that's why the bias arises. But that's the purpose. That's the purpose. Even though bias arises, there are other factors which helps us for that. So in maybe in the first type of non-probabilistic sampling, in convenience sampling, what will happen is I will save my money. I will save my money of going to various places and then taking opinions. I won't require any petrol, right? I'll just step out of my building and just sample people. And that's why convenience sampling, even though is biased, will reduce my money, or will reduce a lot of money, and make it convenient for me, right? So that's the thing. Even though greater risk of bias, it has some other benefits that it serves. One such example of using a non-probabilistic sampling is retail case study. Wherever we have to predict high value purchases, what we can do is use stratified sampling wherever there's imbalance in the data set, and use SMOTE. SMOTE is nothing but sampling minority over sampling technique, right? Again, it is one kind of sampling technique which we would be discussing in upcoming videos, because it takes time and we cannot do that in the same video. So again, always we have to use the best practices for sampling. And the one such best practice for sampling is to prefer probability sampling over modeling and evaluation, because see, we have various biases. Unless we have, if we have some time complexity involved, we have some time bound problems, we have some deadlines to follow, huge deadlines or upcoming very close deadlines to follow, we can go for non-probabilistic sampling. But if we don't have such kind of restrictions, it is always advisable to use the probability sampling for our modeling and evaluation. Okay, so this takes us to the end of this video and to the end of this presentation. So to summarize, we can say, let's start with statistics. There are two kinds of statistics, descriptive and inference. In the inferential statistics, we have a concept of population and sample. And in order to select a sample, create a sample, there are several methods. Broadly classified, there are two kinds of method. There's probability sampling, there's non-probabilistic sampling. In probabilistic, there are four methods. First is simple random sampling, stratified sampling, systematic sampling, and cluster sampling. And when we talk about the non-probabilistic sampling, there are four types. There's convenience sampling, there's quota sampling, there's snowball sampling, and judgmental sampling. Alright. Again, and one such best practice to prefer sampling is to select the sample is prefer a probabilistic sampling. Alright, so proper sampling improves fairness, efficiency, and performance. That's the whole crux of this video, right? So the way you sample something decides how effective or how efficient the model performs. Choose wisely. Alright. So thank you everyone for joining this this YouTube live. If for some reason you are not able to join this live, you can always find that in the Fireblaze's video section. And if you have any comments, or if you have any questions, I will be able to answer them right now. You can always ask them in comments and I'll try to answer them. For more such videos, if you want to see these videos, or if you want to see notifications for this video, you need to subscribe to the YouTube channel, and then you'll get the notifications if there will be any video coming up. Usually we do this every Saturday, and probably same timing every Saturday. The timing might change, but it does happen every Saturday. So be updated with what would be next in line. We'll try to update you beforehand what will be going live about in our next video next Saturday. Until then, thank you for joining, and see you in the next video next Saturday. Thank you everyone.